Hi students, this is part 1 of our lesson looking at the transformation of graphs. Right, so after watching this video, you should be able to understand how circles, exponentials, and rectangular hyperbolas are affected by translations, and then understand how the center of a circle, the asymptotes of exponentials, and rectangular hyperbolas are all affected by translations that we see in the formulas. Alright, so some equations to recall. So for circles, x squared plus y squared equals r squared. So we've got our circle, and then there's our radius. Our exponentials, y equals b to the power of x, where b is just our base. That equation looks something like that. And then our rectangular hyperbolas, y equals a over x. So that's our hyperbolas that look something like that. Some other things to remember. So when we talk about translating, that means we're moving our graph. So we're moving it left and right, and we're moving it up and down. Now remember that also the turning point form of our parabola, y equals a x minus h squared plus k, and remember the effect that h and k had on the graph of that parabola. So remember that we used h and k to refer to the changing of a turning point for a parabola. Now, more generally, h and k just refer to how far left or right in terms of h, right, horizontal, or up and down, that's our parameter k, we move our function. Now for our parabola, those values shifted our turning point. So for our original equation of y equals x squared, when we change our equation to y equals negative 3x minus 4, our h value is 3, so we're shifting our turning point horizontally 3 places, and then we're moving it downwards 4 places. 1, 2, 3, 4. And our turning point has moved from 0, 0 to 3, negative 4, and the rest of our parabola has moved with it. Now, a good thing to remember as well is that in brackets here, the value of h is the opposite to what it looks like is in the brackets. So h is not negative 3, it's the opposite of that. It's positive 3. Now for k stays the same because it's not in brackets in this situation. So here k equals negative 4 because it is not in brackets. Alright, so in terms of circles, exponentials and hyperbolas, we can still use h and k to do some translations as well. So for a circle, the standard form is given by x minus h squared plus y minus k equals r squared. Right? So once again, we've got x minus h in brackets. So our h value will change signs again because we've got, if h is negative 3, then what's in brackets here will change to x plus 3. That h value changes sign because of that negative. Now for our circle, the k value changes sign as well because it's in brackets. It's not on its own. It's not a constant on its own. It's in here with some brackets. So that k value changes sign too. Now, h and k in this situation are the coordinates of the center of the circle. So previously, when we had x squared plus y squared equals r squared, our center was at 0, 0. Now our center is at hk, and our radius is still r. Now for our exponential equation, y equals b to the x minus h plus k. Once again, h is the opposite of what it appears in the power because it's right next to x. Really, it's in brackets. There's invisible brackets there around that power. So h is the opposite sign, moving it left and right. And k is on its own, right? So it's not in brackets. It's not with another variable. So it keeps its sign. It stays the same. And now the asymptote of our new exponential is y equals k. So this k value shifts our graph upwards and it moves our asymptote from y equals 0 for our normal exponential. It shifts it up to y equals k. Now the equation of our hyperbola does a similar sort of thing. our hyperbola had asymptotes at x equals 0 and y equals 0. So if we shift it horizontally, our asymptote moves to y equals h. Once again, h is in brackets with that x in the denominator. So that will have a sign change from negative h to positive h. So the h value changes sign from the formula to when we use it to do our graph. And the k value is on its own, not with a variable, so that stays the same sign. And that horizontal asymptote, where y equals 0, that's been moved up to y equals k, or down if k is negative. And that vertical asymptote at x equals 0 is moved left and right by a number h. Alright, so let's do some applications of this. What are the translations of the following graphs? Y equals x, sorry, that's not even a y equals, that's x plus 3 squared plus y squared equals 9. So looking here, looking at x, so x is our horizontal direction, so we're looking at h in here, and h is the opposite sign to what's in brackets, so h is negative 3. Now here with y, there is no k value, so k must equal 0. So what are the translations of this graph? Well, h value is negative 3, so we can say it's moved 3 units, and the negative direction is to our left, so it's moved 3 units left. For our exponential, we've got our h value up the top there, opposite sign, h is 6, and our k value is here on the end, k equals negative 2. So in this case, our exponential is moved 6 units right, because it's a positive 6, moving to the right, and 2 units downwards. And because our k value is negative 2, we've moved it downwards 2 places. Alright, in this second lot of problems, what are the equations of the asymptotes in the following lines? Well, our asymptote for our exponential is the line y equals k. Our k value is 2, so the line for our asymptote in our exponential is y equals 2. So for our exponential, that might be the line y equals 2, and our exponential will look something like that, never crossing that line y equals 2. And then for our rectangular hyperbola, this one here, okay, our asymptotes are x equals h and y equals k. Looking at this, our h value is with this x term in brackets basically, so it's the opposite sign, so x equals negative 5, and k, there's no k value on the end, so y equals 0 is the asymptote of our rectangular hyperbola, so that would be something like negative 5 will be here, and our y equals 0, and our hyperbola will go something like that. Right, and that's how we can apply transformations to talk about where graphs move left and right. Alright, so after watching this video, you should be able to understand how circles, exponentials, and rectangular hyperbolas are affected by translations, and understand how the center of a circle and the asymptotes of exponentials and rectangular hyperbolas are affected by translations.